So last week, we did a problem with the bacteria in the swimming pool. And if you remember, I kept making the joke about if you're a swimmer, that's what chlorine is for. And ultimately, what we ended up doing is we ended up trying to figure out how long it would take until there were 3 million bacteria in the swimming pool. And we decided to use this equation of 3 million equals 1,500 times 2 to the t. And we left it in that format, but we could have written this a little bit simpler. We could have written it as 2 to the t equals 2,000. Do you know how we could possibly get it in that format? John? If we divide both sides by 1,500, we'll be able to convert this into the same. 2 to the t. And you can even type that in the calculator if you can't do it in your head. The 3 million divided by the 1,500 gives us the 2,000. And what we just did is we isolated the variable to help us solve. And we're going to explore this idea a little bit more of solving. But the question ultimately ends up to be, well, 2 to what power equals 2,000? And the only way that we can really solve something like that is to use our table and our calculator. At the time, we had no way other than our calculators to solve this equation, because we need to isolate x, and x is an exponent. So we need to find a way to isolate x and undo taking 2 to a power. So what we're going to do for a good portion of this week is we're going to learn how to use logarithms to help us solve this problem and many others like it. And on Friday, we talked about the logarithms a little bit at the end. And what we ultimately came up with, even though I got ahead of myself then, is that a logarithm is another way of writing an exponent. And this y equals b to the x, notice that the exponent on here is what this equals. It equals the exponent. A logarithm is another way of writing an exponent. By the way, y equals b to the x and log base b of y equals x, they mean the same thing. So if we can get past this word log, we can solve these types of problems. So let's use our definition of a logarithm and rewrite each of these exponential equations as a logarithmic equation. Well, once again, what we just talked about is the fact that a logarithm is another way of writing an exponent. So in this problem, letter A, 10 squared equals 100, the exponent is 2. That's what our logarithm is going to equal. We're going to put in the word log. It's 10 to the second power. 10 is the base in this problem. And when we write a logarithm, we drop that 10 down so that it's a subscript. So it's dropping like half a line. It's a little bit smaller. Well, we have 10 squared equals 100, so the only value that we haven't touched is 100. And that's going to go right here. Notice that 10 is the base. And both the exponent, 10 to the second power, that 10 is the base, log base 10 in our logarithm. It's both the exponential and the logarithmic form, it's a base. Also notice that the logarithm is the exponent to which 10 is raised to get 100. I want to say it as many times as I can. A logarithm is another way of writing an exponent. What the logarithm equals is the exponent. So when we take a look at letter B, 6 squared equals 36, we can write our logarithm here, and we can write down what it equals. And once again, it equals 2, because 2 is the exponent in this problem. And it's 6 to the 2. 6 is the base, so drop that 6 down a little bit when you're writing. It's log base 6, and then we only have one piece left, which is the 36. When I say one piece left, there's really 3 pieces. There's the base, there's the exponent, and then there's that other number. And typically, we can write down the base and the exponent first, and then we can fill in that other number. Same thing here on letter C. We can write the logarithm down. We can write down what the logarithm equals, because the logarithm is another way of writing an exponent. It's going to equal 5. Well, that 5 is attached to the 2. So this time it's log base 2, and then we only have one more piece to deal with, which is the 32. And we should notice that the same pattern appears in B and C as it did as in A. The logarithm is another way of writing an exponent. So not something new based on how it really was presented in our last section of notes. But what we just did is we wrote everything in logarithmic terms. Now let's go the other direction and write something that's written as a logarithm start, write it back as an exponential. So I'll take this opportunity to say that a logarithm is another way of writing an exponent. So what this equals, on letter A, it equals 2. That's the exponent in this problem. It's going to be 4, log base 4 squared equals 16. What the logarithm equals is an exponent. Letter B. Log base 6 of 1 equals 0. Rewrite it with an exponential. It's 6 to the 0 equals 1. In both of those statements in the first two, A and B, 4 squared does equal 16. And 6 to the 0 equals 1. That gives us a good method to check. But we're not always given everything that we need to be able to say, oh yeah, that's a true statement. As we look at letter C. Log base 3 of n equals t. Well, this one, when we convert it, log base 3. What the logarithm equals is t. 3 to the t equals n. So far, we've converted from exponential to logarithmic, from logarithmic to exponential. So let's use what we just talked about to kind of help us solve these. And once again, there's 3 parts to a logarithm, at least in my head. There's the base, there's the exponent, and then there's the other number. So in terms of our definitions here, it says, let's start by using the definition of a logarithm to solve the following. Show all of your work. Well, what we're going to do is we're going to convert this logarithm back to an exponential. So this one's going to become 9 to the x equals 81. A logarithm is another way of writing an exponent. What the logarithm equals is an exponent. If you've been doing the quick recalls, this should be very quick for you. What does x equal? 9 squared equals 81. Letter B. Convert. Convert the logarithm to an exponential. Log base 8. There's the base. what the logarithm equals. 3 is the exponent equals x. Again, if you've been doing the quick recalls, you probably know the answer, but there's nothing wrong if you have to say 8 cubed gives you the 512. It's just quicker if you know what it is already. Letter C. Maybe you have to do a little bit more work, but rewrite the logarithm with an exponential. Because once you get that logarithm out of there, it doesn't seem to be so intimidating. And sometimes people see logarithms and they think, oh my gosh, this is so hard. But if we can just rewrite it, then we don't have to worry. At least I hope. So it's going to be 5 squared, log base 5 of 3x plus 1 equals 2. The 2 is the exponent. Here's our other number, 3x plus 1. And we have to do a little bit more work on this one to solve. But this use our solving equation techniques. 5 squared is 5 times 5, which is 25. Equals 3x plus 1. Well, ultimately what we're trying to do is we're trying to figure out what does x equal. So we're going to subtract 1 from both sides. And we get 24 equals 3x. And 3 times x. Well, our inverse operation is to divide by 3. And we end up with x equals 8. I'm going to pause the video here to give you a couple minutes, probably not more than 5, to work on these next 3. Here are the answers to those 3. Do we need to do any of these 3? Okay, I'll take that as a no. Hopefully, you now have an understanding of the relationship between exponents and logarithms. In logarithms, just as with exponential expressions, any positive number can be a base, except for 1, and we'll look at this a little bit more later. But just a few more little facts about logarithms. First of all, a logarithm that has a 10 for a base is called a common logarithm. And it's expressed simply as log. It's not necessary to write the base, although if you prefer to, that's fine as well. Calculators are programmed to evaluate common logarithms. So no matter what calculator you have, if you look at the screen here, it's the 4th button from the bottom. So you've got on, and then you store, then ln, then log. That log is the common log button. It has base 10 there. If we take a look at this, I'm kind of going out of order. It says use your calculator to evaluate log of 78. Write down what this means in terms of exponential expression. Well, let's do log of 78. So 4th from the bottom button again, 78. Close the parentheses and press enter. Gives us this big long decimal. But here's what it means. When we're actually using our calculator to find this, what it means is that we've got log of 78. It's actually log base 10. And I know, I just said we didn't have to write it down, but if it isn't written, it's understood to be 10. And then we can put in equals x. So if we convert this, then it becomes, convert it from a logarithmic form to exponential, it becomes 10 to the x equals 78. And what we just found out is 10 to what exponent gives us 78? Well, it's going to be x equals 1.8921. That is a point there. The reason that I put the 1 is the number after that 0, which is 9, is 5 or greater. So I rounded that 0 up to a 1. And by the way, I just rounded that number to the 10,000ths. 8 is in the tenths position, 9 is the hundredths, 2 is the thousandths, and then 1 is the 10,000ths. And oftentimes it will be requested for you to round either to the 1,000th or the 10,000th position. There are logarithms that use the irrational number e. And e is a number kind of like pi. It has a value, but because it's a non-repeating infinite decimal, we just say e, and then if we need it somewhere, we can use the e button to figure out what it is. 2.718281828. It's just another number, kind of like pi. It's e represents that big long decimal, is what it does. And the function y equals log base e of x is actually the natural logarithm. And it has a base of e. The shorthand version for y equals log base e of x is ln of x. Calculators are also programmed to evaluate these natural logarithms. So let's evaluate the natural log of 126. As we look at our calculator screen in this particular case, the natural log button is the third button from the bottom on the left side. It just says ln on it. So in this case, we type in ln of 126, and we can press enter. And again, we get this big long decimal. Well, what is the calculator really finding when we type in something like this? So I didn't follow my own directions to write this exponential expression first to make sure we understand what we're finding. This is what we're finding. So this is natural log of 126. And our base of the natural log is e. It doesn't have to be written, but we oftentimes will convert to an exponential to be able to solve this. So when we rewrite this as an exponential, it becomes e to the x equals 126. So what we're actually finding is e to what power gives us 126? Well, we already found out what that is. In this case, it's 4.8363. We look at the 8 to determine the fact that we're going to make that fourth decimal space not stay 2 but go up to 3. 8 is 5 or greater, and that's what causes us to round that position. Just a few more practice problems here to finish. We want to evaluate the following using natural logarithms. And on problem A, we can't type this into the calculator yet because we have the natural log of x. If we had the natural log of a number, we could type it in, but we don't have that. So what we have to do is we have to use our hint here, and it says write the logarithmic expression in exponential form. The thing that we need to know is that the base of a natural logarithm is e. And once we know that, then we can write this in exponential form. It becomes e to the 7 equals x. And now that we have it in this format, then we can type it into our calculator. There's 2 places on your calculator where there's an e. I oftentimes use second and then the ln button, which gives us e to some power. In this case, we need e to the 7, which gives us this big long decimal. There's also an E on the division symbol, but we have to do second and E, but then we'd have to use the caret to get to the 7. That's another place that we can use that. On the TI Inspires, they have their own E button. But either way, when we type that into the calculator, we get the value here of 1096.6332. And again, I take the time to point out the fact that here's a 5, which means that we're going to round that 1 up to 2. Letter B, e to the x equals 85. We need to write the exponential expression in logarithmic form, in this case, to be able to find that exponent. So if we write this in exponential form, what we end up with then is the natural log. And I'm using natural log because it does have base e. The natural log is going to equal x, because whatever a logarithm equals, whether it's a common log or a natural log, a logarithm is another way of writing an exponent. So the exponent in this problem is what we equal. That means the 85 goes here, and I really should have written down the fact that we've got that base of e. And we don't really need the e, because in our calculator, but we're going to type it in. The natural log, again, third button from the bottom on the left. There's the ln, and it's 85. Close the parentheses. Then we get our decimal there of 4.44265. And once again, we look at this 5, and because it's a 5 there in that 5th decimal position, we're going to round that 6 up to 7. So we get 4.4427 equals x. Lastly, evaluate log of 10 and log of e. So we're going to use our calculator to finish this last problem. Log of 10. Type it in. Log of 10 is 1. Let's look at natural log of e. And I'm going to use the division e. But if you happen to use second ln, you do have to put that exponent of 1 into the problem, or you're going to get an error on your calculator. But the natural log of e, either way that we type it in, gives us 1. Well, why does that seem to make sense? Well, here's why. If we take log of 10, that means it's really log base 10 equals x. And if we convert this logarithm into exponential format, we will get 10 to the x equals 10. And 10 to what power equals 10? 1. If we look over here at natural log of e, it's the same reasoning here. Natural log of e, well, the base of that is e. And we need to know what the exponent is, because that's what we're asking for here. If we convert it to exponential form, this is e to the x equals e. And e to what power equals itself? X equals 1.